Okay. Good. Good afternoon, evening, more like. It is holy. It is day, I believe, 68, 68 of coding every day. Well, I've been slacking on applications the past couple days. I need to ramp that up. Um, I was trying to make a script for applying to stuff, and it just hasn't gone that well. So I think I'm going to just go back to manual apply, whatever. Work on it maybe another day. Um, yeah. So today I had my computer. Okay, I didn't go to my computer architecture class today. I'll admit it. Like I said, I woke up not yesterday, but the day before that, I took a nap, and then from like 5 to 9 p.m. and I couldn't get to bed um until like 9 a.m. yesterday. So my sleep schedule was just all fucked up. So I set an alarm to wake up for that class, and I woke up and I was in shambles. And then my group mate sent me an email. Like I checked my emails to see if maybe by the grace of God it got canceled. And he was like, "Hey, don't feel good today, not going in." And I'm like, "I'll do the same." So we need to look at those lecture slides today. Um, Also, due at midnight tonight is my first two assignments for linear algebra, so we're gonna do that as well. Other than that, I have nothing else to do this week. But we're still gonna be working on stuff this week for the following week because a couple things next week that are maybe not next week, but I know we have one of my classes is called computation computer system principles. Um, which is just like computer systems, operating systems, all in C though. It's like the C using C to understand how a computer works. So it's a pretty cool class. But there's a project due on the 25th, I believe. So we'll start working at that. Um, I would also like, so I want to do at least one LeetCode today on top of these going over lecture slides and doing my linear algebra homework. And then if I have time, depending how I'm feeling, if we have time, kind of want to work on Quibbly, the old task manager app. Um, because looking back at it, I'm like, I don't think I was too far off getting that thing to be working within a few days. So I do that because I do really like the idea still to have something of my own that I can just tweak over the years to, you know, keep track of tasks that are due and um, keep notes on stuff. So So yeah, so that's the plan. Um, Lecture slides, linear algebra, leak code, and maybe. Oh my god, I'm tired. And then maybe um, work on that application. So I'm gonna check that DM that is down here, and then I'll be back. Okay, I'm back. Mm-mm-mm-mm. Go like that. Okay. Let's. What did I say we're doing first? Linear algebra? No. Other thing. Wait, I'm gonna pause again so I can bring stuff up without, or rather not leak my professor's like details. So I'll be right back. Okay. Um, One thing I wanted to do before we look over the slides for what I missed today is he had a survey of knowledge, and I kind of felt like a fraud when I went through it because there was a lot of stuff that I should have been able to um talk about, and I just didn't come to mind. One second. Okay. So I want to go through with ChatGPT and just kind of like look at this. So what happens in the fetch stage of a fetch execute cycle? See, like this, it's like a fetch execute cycle. I don't really know exactly what it means. I'm guessing there's probably some deeper meaning to what it is, but at taking it at like a face value, right? it's fetching some instruction and executing it. So what happens in the fetch stage of a fetch execute? It just fetches an instruction. Like, I don't know. Yeah, the CPU retrieves next instruction from memory. So the program counter holds the memory address to the next instruction. The CPU sends the address to a memory address register. A request is made to memory to fetch the instruction. The retrieved instruction is loaded into memory. The instruction is transferred from the memory data register into the instruction register where it's stored and decoded for the next stage. PC is incremented to point to the next instruction. Okay. What is the difference between register indirect and immediate addressing? I actually have no idea. Immediate addressing, no operand is embedded directly within the instruction itself. No memory or register lookup is needed to retrieve the operand. Okay. Um, what? Move value 10 into register 1. The value 10, yeah. Fast execution. Register indirect. So this is move. Wait, load the value in memory from. So, immediate addressing is taking an exact value and putting it into a register. Indirect is taking a value from somewhere in a different type of memory, a different type of register, and moving it into a different type. I see. Um, what does the tag field do in a cache line? Like, this is also something I should know because I remember doing cache like stuff and there being a tagline. I think it like has to do with, I don't even know. That's what it was. Tag field stores a portion of the memory address associated with a cache block. When the CPU requests data from memory, the tag field is compared with the corresponding portion of requested memory data. If the tag if it matches, it's a hit in cache, meaning the data is already in cache. If nothing matches, it's a miss, and the required data must be fetched from main memory. Yeah. Explain the difference between direct map and two-way set associative. Again, these like direct and indirect things. A direct map cache is the simplest type of cache. Each memory block is mapped to one cache line. For a 16-line direct map cache, memory address are mapped as block 0, line 0, block 16, A two-way set associative cat allows each memory block to be mapped to one of two cached lines. Instead of mapping one block per another, the cache. Okay, so in the mapping, each block directs to one line. Each block can go to one of two ways in a set. Still don't really get that one. Fixed length. Each instruction performs a single operation, making things easier to decode. Example, instead of having a single complex instruction like that loads, multiplies, and stores in one step, or it would load, multiply, and then store all separately. Fetch, retrieve, decode, execute, load, or store right back. Add register 1, 2, and 3. Add register 1. Add the value from memory register. Okay. Compiler friendly. Okay, I see. How does pipelining speed up? I don't even know what pipelining is. Pipelining is a technique used in modern CPU architecture to improve instruction throughout by overlapping to execute multiple instructions. Is this not... Is this not like parallel processing? I've never known actually what those differences are. In a non-pipeline CPU, instructions are executed one at a time. To fetch one, decode it. Okay. So it usually take 20 cycles. The fetch execute cycle while pipelining. Fetch. Okay. That's cool. I need to get used to the bathroom real quick. I'm gonna ask it this and pause and then be right back. I took a little longer than I should have. My bad, gang. Okay. We were looking at ChatGPT's response. Pipelining is not parallel processing or multi-threading, but it does share some similarities. I'm gonna put on some music to be honest. Um, Pipelining increases instruction throughput by allowing different stages of multiple instructions to execute at the same time, but it does not execute multiple instructions in full parallel. Okay. So definition. Pipelining overlaps execution of different instruction stages. Parallel processing runs multiple instructions at the same time across multiple cores. Multi-threading runs multiple threads, smaller tasks of a single process concurrently. Okay, so all of these, a different part of the CPU is running. Multiple threads share CPU time, but may not run simultaneously. One instruction progresses through multiple stages simultaneously. Fetching instruction A while decoding instruction B and executing instruction C. So never is the same type of instruction happening, but different processes are happening at the same time. So utilizing different stuff. Okay. Running different applications on different cores. And then multi-threading is a web browser running a UI, network, and JavaScript. Okay. The difference between multi-threading and parallel processing still is a little weird, but... So is it like multi-threading is working on the same task but in smaller tasks, and then parallel processing is working on like completely just separate things on different cores? So does multi-threading use the same resources? Each process has its own memory registers and CPU. All threads within share the same memory. Okay. That's what I assumed. Each process is truly independent. Threads share a single core. Or run if multi-core threading is enabled. Okay. Threads share the same memory space. Each process has its own memory space. Okay. Okay. I see. Okay, cool. The arithmetic, logic unit, and control unit are two key components of the central processing unit. So ALU performs arithmetic with logical operators and bit stuff. Management and directs operations within the... I see. I was like in the moment thinking about like how they're like directly like functions that they share. So like that's not like how they work together. There's a difference between being paged. This is the thing. Paging divides memory into fixed size pages. Segmentation divides memory into variable size segments. Yeah. Uses page number plus an offset. Uses segmentation number and offset. Maps virtual pages to physical frames. Paging is memory management technique where virtual memory is divided into fixed size pages and physical memory is divided into frames the same size. Virtual memory is divided into pages but for kilobytes each. Physical memory is divided into frames of the same size. A page table keeps track of which page maps to which physical frame. Suppose a process needs 20 MB memory and the page size is this. The process will split into 3 pages. These pages may be loaded into a non-continuous frames with physical memory. Page 0. Okay. I'm pretty sure I've seen segmentation within memory before. And kind of how you can like decode that. And also compress it. Ah. So now I wanted to go to looking over the lecture on this today. We're just gonna skim through this. Oh. Wow, ALUC, CU, a lot of know it. So people were most confused on addressing crazy. Assembly language view. Assembly language view. Execution. Content abstraction. I low-key want to like go watch the lecture in real time. Typical early instruction set, one address, Integer only, add, subtract, multiply, divided, optional. Small address space, easily addressed, no supervisor state, program.io. Program in assembly, then later in very simple high-level language. The high-level language is basic. I was actually watching a video today of someone programming, making a 3D sphere using BASIC on an Apple II. Just because I wanted to see the Apple II monitor, really, since it's supposed to arrive tomorrow. It's cool. I hope it works. I also had the idea of turning my keyboard, I don't know if you can see it, it's the kinesis of turning my keyboard down the line into kinesis keyboard. Down the line I want to get no, the other one. I don't want Bluetooth. I want to get this. It's expensive. I mean, $450 is not cheap. But I want to get this down the line, and the idea I had was the base of this thing unscrews, and there's a lot of hollow room in the center of this. And so I want to make a new base that, like, you can kind of see, if I can get this back up, you can kind of see that, like, there's like a little divot in the bottom, and then there's like a lot of room. I kind of just want to box it out. You can also see the screws, it just comes off in the bottom. I want to box out the bottom, so it's just boxed and lays on the ground, and put in like a Raspberry Pi into this with like a battery and stuff like that, and then get a monitor and put this thing on like little rubber blocks, right? So like it can sit down and lay down, and then have a monitor that I can pull out and pull up, and then it's like a laptop, but I get to use my ergonomic keyboard. I think that would be fun. Okay, semantic app. Rise of high-level languages, compilers. Multiple registered, large address space. Mainframe very costly to lease. Isn't this the... string move system calls, the for loop, pointer chain, enter the micro. Microprocessors began simple, 8-bit, few registers, limited instruction set, quickly started to evolve, taking lead from mainframes and mini computers, several false starts and blind alleys, 8 general purpose registers, 6 segment registers, instruction pointer, Intel instruction set, register, immediate, direct, base to placement, index to placement, scaled. Jesus. Operands, we had an integer of size 8, 16, 32, 48, and 64 bits. My god. When was this? Vector. This shit's insane, bro. Processors are insane. Reinvention of risk. Simple instruction sets leave more chip space, faster to design, easier to compile for, easy to build, faster to decode, faster to execute. Cache tags, L2 cache tags, floating point unit. Bell Labs, HP. X86 becomes a virtual ISA. I want branch prediction. This always sounds so cool. Tensors. Okay, cool. Alright. I'm gonna go look through that lecture, like the video lecture real quick, and then we'll do this homework. Okay. Wait. Okay. So I already did the first question on this earlier, which was just a simple row operations. I've already taken a linear algebra class, so I actually haven't read anything on this course yet. I'm just trying to go off previous knowledge, but find point when I set lies on the line. Holy that was freehand. Am I crazy? Okay. There should just be 1, 2, 11, 1, -1, -1. I messed up this last one though. This is supposed to be a -7. I had to change it earlier, but I hate putting the line here. But I do kind of want it because we have an 11 there. I suck at dashed lines. No, I can't do it. There we go. Good enough. Okay. So all we want to do here, just row 1, take row 1 and subtract it from row 2. And that'll equal new row 2. So 1, 2, 11, 0. Subtract 2 from that, -3, -12. Wait, did I mess that up? Row 1. No, it's row 2. I wrote this wrong. Sorry. Take row 2 and subtract it from row 1. That's going to be equal to row 2. So this is again 1. Take row 2, subtract this, -3. -1. Yeah, I was right. But I wrote that wrong. That's why it was tripping me up. 12. Okay. So now I want this 2 gone. So we can, what? I can take 3 times row 1 and add 2 times row 2. And that'll equal row 1. Wait, no. What am I saying? This would change this off of a 1, but I guess that really wouldn't matter, would it? Because we'll just divide at the end. It's been a while since I've done this. Let's just go with this, and we'll say that this is what? This is going to be 3. This is going to be 6 plus. Well, actually, 2 times -3 is. Yeah, -6. 0, and then -24 plus 3, -21. So can I just divide both of these by 3? And get 1, 0, -7, 0. Well, this would be divided by. Is -3 divided by -3 +1? Okay. So do we have -7, -4? Nope. I wonder if it's like a 3, 4. Is it +3, +4? How is this +3? 2 times row 2 is -24 plus this is -21. -21 divided by 3 is -7. So I definitely messed up somewhere. What did this didn't even do matrix stuff. What did this do? From equation 2, x1 is equal to x2 minus 1. I wonder if O4 can decipher my math here. This was 11. Oh my god. Oh my god. It was 11. Am I stupid? And then you make the next pivot row this by just dividing instantly. And then you take row 1 minus 2 times row 2. Yeah. And that's row 1. Oh my god. Embarrassing. Okay. I hope, by the way, that like if my professor saw me like using ChatGPT to help, I want to get, kicked out of the school. That'd be pretty bad. One second, I'm gonna go check the academic policy. Okay. So in his thing, it says do not use AI like ChatGPT to complete homework assignments. It doesn't say in any form. I interpret that, okay, as doing it, completing it, using AI. I feel like it'd be crazy to kick me out of school for using it for assistance. Like showing me going through it, understanding where I messed up, and just using it as quick. Like if I message a TA right now, it may take an hour. I don't have an hour. Just saying. So don't kick me out. And also, I was like, I don't know if I can record Pearson content, um, because it's behind like a paywall and stuff like that. Hopefully, I don't get like banned or fined or something. I don't know. I looked it up and it didn't like nothing popped up instantly. So, oh well. Hopefully, I don't get my life ruined from recording myself working. My linear system has been reduced by row operations. Or he'll continue the appropriate row operation to describe the solution instead of the original. Wait. I'm confused with this. The archive matrix of linear system has been reduced by row operations to form shown, which what is it like? Is that a free form? That last line, is that like a free variable? I'm pretty sure because there's no constant. I see. It looks pretty consistent. That one I literally just eyeballed. 3 lines. I think so. Again, this could all be wrong. I'm literally just guessing, and if I get it wrong, I'll look into why it's wrong. But I'm pretty sure 2x and negative 2x are going to be crossing. Maybe. Determine the values of h such that the matrix is matrix. Uh, uh-oh. Uh-oh. Huh. So consistent is just it has to have at least one solution. But like if I put 0, let's say. Oh, I guess if I did 0. No, because I want a 1 there. So if I did a 0 per se, and then I multiplied that whole row by 4, and then I added it to the other row, and then I divided by 12. It'd be weird, but like it's true. Like I'm pretty sure if I put a 0 there, it'd be fine. If I put a 1 there, it'd be fine. No matter what, it would be fine. I, I'm honestly kind of confused if why this isn't just consistent on every. Wait, what if h is -2? For the system against this, we would need a row of form 0, 0, 0, which happens if 8 plus 4h is equal to 0. And so -2. Really? If I had 1, -2, 5, -4, 8, can I not just... Can I not just times this row by 1/2? And then just, I mean, sorry, not 1/2, 1/4. And then add it into here. So if I did 1/4 of this, this is going to be such a weird number. This would then become -1. Well, this wouldn't become anything, actually, never mind. Okay, I guess so. Oh, sorry about that. Okay. Determine the values of H such that the matrix is an augmented matrix of a consistent linear system. Guess and check. I mean, if H equals 0, I mean, it can equal 0, though, I'm pretty sure. I need to look at the textbook. These ones are like, oh, I see now. I see now. It's for, if we were to zero, we're just trying to find an example of something that would zero out like a row given. So like if we zero out this first column, right? If we were to say like what it says, 4 times this added to this, now we have 0. What times 4 plus this value is going to give us a 0? Well, it's going to be a -2, right? And this zeroes this out. It doesn't matter what this last value is. So if I can get, now what happens when the H is here, right? Okay, I see. We just want to zero out a row. So if we said, now we have multiples. Both of these are multiples. So if we said like, for instance, row 1, okay, we have negative 25, 15, h, 5, negative, whoa, negative 3, 3. Right. Let's say we want to change row 1 to be what I just don't understand. Is it the row? Is it either row we can zero out? So like here it zeroes out just that h row. So it doesn't matter. Okay, let's just do two operations. Let's say row 2, or no, row 1 is going to equal adding 5 times row 2. Right. So row 1 plus 5 times this. So 5 times, so we have 50. Or isn't it supposed to make this like, but it's for a value of h. So I would say it's this. No. What? But like, oh wait, it says it here. If instead we had this. Oh, it's just what the final result of this is. So this would be 50. This would be 0. And h would be 15. Are we treating this as a 1 or a 0? Just say it's 15. Okay, and then 5, negative 3, 3. And then I just say row 1 is equal to row 2, or 10 times row 2. So take this value and wait, no. Row 1 minus 10 times row 2. So it becomes 0, 0. But wait, wouldn't this become... Because 0 minus 30 becomes a negative 30. No, 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 no. Maybe on that first one I messed up. Maybe I want to do something like... Like 5 times row 2. Because if I did 5 times... Or, okay, negative 5 and add it to row 1. And so this way, this is a 0. This is 30. And this is negative 15. But even in this situation, if I did times 10 and then add it to this, right? It just doesn't work. I need help. I don't know, I'm struggling with this. Are you kidding me? I'm not even going to look. I literally just saw it printed back to me. This is a negative 25. Oh my God. Five times row 2 and adding it to row 1, I'm pretty sure just makes this an inconsistent system now. 5 times 5, add it to here, 25, it zeroes it out. 5 times negative 3 is negative 15, add that to this, it zeroes it out. And so then this will just be 15, negative 3, 3. So it's 15. Sorry, it's 15. When not negative 15? Negative 15. Why wouldn't it be... I hate it here. Wait, the matrix is the augmented matrix of a consistent linear system if H. But if it's 0, 0, isn't that a... Oh. Okay, let's try this again. I still don't get, though. Oh, we want to zero out the whole row. So it's what would the value of H be if H was at... I understand it now. Okay. So what I can do here... It's been a while since I've done... It's been literally like years since I've done linear algebra. So bear with me. Um... So again, I can just do row 2... Sorry. Row 1 is going to become... What is this? 5 times row 2? Add that to row 1. So zeros out, 2, -7. Or sorry, this will be 5 times. So this will be -15 plus h. So this time this will actually be 15. And not -15. Okay. Cool. You can reverse anything that you do. Two matrices are row equivalent. Same as full two matrices are... Two matrices of row exist with a sequence of row. I think this is correct. Yeah, because I think you can have like something with an identity matrix or whatever. Find an equation involving G, H, and K that make this automatic matrix correspond to a consistent system. Okay. What just how do you solve something like this? Um, no, I get that. It's like I can solve the system. I just don't get what's okay. Let's go through and see if we can perform operations and find some inconsistency here. Is there a way to remove this? Well, I see. So vice versa, if I add either of these rows to the other, it'll be inconsistent. I still don't get though, like. So taking this. So 4 times. Oh, 4 times. I don't get why it's 4 times G though, but okay, 4 times the row of G plus. Alright, so it doesn't matter. Cheers. Cheerio. And I want to be.
Feel like I want to be inside of you when the sun goes down. As long as I'm gonna be around you.
Is it just this again?
When the sun goes down, yeah.
Oh, wait. Right? Yeah, it should be.
Feel like I want to be inside of you when the sun goes down. As long as I'm gonna be around you when the sun goes down, yeah, 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 yeah,
My God, I feel like I pulled something on my torso, bro. Oh, interesting.
when the sun goes down, yeah.
Hmm. Well, actually, there's a 4 here. Wait 1 second. I'm actually sorry about that. I'm happy with this. I think the key here is like I can obviously do something here that would zero out. Well, actually, I could just add this line to this, zero this all out, and then do -2 times this row, add it to this row, and go somewhere along those lines. I want to get rid of this 2, so we can just say row 2 is going to equal -2 times row 1. Next, I want to zero this out. I can divide this by -2 by 2. You get 0, 1. And then I can just add. Is it really 13 over 2? Ugh. What is this, -13 over... You know what? I don't want to deal with that, so I'm just going to say... I'm just going to say row 3 is equal to 2 times row 3 minus row 2. Much prettier. Actually, fuck. Maybe I should have subtracted row 3 from that. I'm spending way too much time on this. But actually, I would like to say row 2 is equal to row 2 minus row 3. Okay, now I can say like row 3 is going to be equal to row 3 minus row 2. It's just 14 now. If I did 5 times row 1, minus so this becomes 6 times this, then add it to this. So this is negative 30. Well, this is going to be minus that. So this will actually be negative 60, negative 80. Wait. Negative 84. Well, that's kind of ugly. Running out of time on this quiz. One second. I'm back. God just willed it into my brain. It was crazy. It just like came to me. So we're on the next one. We have computers, you know. I should be letting a computer do this for me. That's what they're good at, is matrix multiplication. What is this? 4 times row 1. Negative 4 times row 1 added to here. So 0. Negative 5. Negative 9. And then what? This will go to... I want to zero this out. I mean, I can just do 3 times row 3. Three times row 3. And then add that to 5 times row 1. So 5, 0, negative 5. So negative 27. Negative 32. I think. There's no way this is... If I divide both by 5, we're at... negative 32 over 5. And 9 over 5. Negative 9 over negative 5. I'll be right back. Under further investigation, this is a 10. Not a, not a 9. So this becomes 32 over 5, making this, negative 7, 2. That makes more sense. I was like, there's no way it's 2 fractions. Okay, last one. Last one. I'm kind of blanking on how you do this again. What if you did half? I'm gonna finish this one up off screen real quick. I can just think better. Wow, we went crazy, guys. Yeah, definitely need to read over and work on that a little more. I waited till too late and I still wanted LeetCode because technically we haven't programmed today, so yeah. We can... Bro. My god, Zen browser. Okay, bam bam. Done and done. Almost 2% done. Oh my god. Okay. 1 second. Alright. Time to LeetCode it up. 1 second. It's hot in here. I'm gonna shut the heat vent. Okay, we're back. Took me a little while, but we back. Yeah. Let's do LeetCode. Oh my god, I've done this problem before and it was so hard. Oh my god. Oh my god, I remember this was one of the hardest problems I ever did, like when I wasn't doing LeetCode. And it was something with 2 pointers, one at the start and one at the end. Oh, okay, let's read it. So you're given an integer array height, where for each value there are n vertical lines drawn such that the 2 endpoints find 2 lines that together with the x-axis form a container such that it contains the most water. Okay. So we have a height of 1 and a height of 8. Wait, what? No, this is different from what I did. It can just go through a pillar. So it's 7 high and it's 1, 2, 3, 4, 5, 6, 7. I'm so confused. There are n vertical lines drawn such that the 2 endpoints are I0 and I. I'm so confused. What does this mean? And how the fuck is this? How is this like inclusive but only on one side? So it goes up to a line of 7, right? Maybe it like starts at index but ends at value. Like it starts at the I value, but then it ends at the height value. Okay, so if we're saying that, right, we just have 2 pointers and we'd say, okay, is the index of this left pointer times the height of this right pointer. Well, the difference between this index and this index. Right, so it would be like, in this situation, we're at the index of 1, 2, 3, 4, 5, 6, 7, 8. So 1 to 8. So we take this value, this index value, and we minus by this index value. We say if this multiplied by the max between these two. Okay. Max area. And we will return max area at the end. We're also going to have left and right. Left is going to be 0. Right is going to be and wild. Okay, while left is we want to say, okay. Right, so this will give us our current area, or current max area. Or no, just current area. Oh wait, no, it won't be the max. It's going to be the min. The min between these two, because if it was max, then it would technically overflow. And so we want to say that the max area is equal to the max between max area and the current area. Okay, the only thing is when do we want to increment? Like, I mean, you could exhaustively search both combinations, but you want something conditional. So like here, right? Maybe I push in there needs to be a conditional on how I'm moving right and left. Because, like, if I went here, right, and it was like, I guess what you could say is say, like, okay, between here and here, this is the max. So we're going to keep it. So we're going to. So if height at, let's say, left, if this value is greater than height at the current right, then we want to increment in the other one. So we want to say right plus equals 1. Else left plus equals 1. Right? Because this will be like, so we start here and we're like, okay, is this little value bigger than this one? Nope. So we're going to change this left pointer in 1. Also, this should be minus equals 1. So we're going to put it in 1. Is this one bigger than this one? Yep. So we're going to move in 1. Is this bigger than this one? Yep. Then we're going to move in this one. Now, what if they're equal? If they're equal, it doesn't matter. So we can just move in the left one. Let's try this. Am I the goat? Wait, am I the goat? I actually just got that first attempt. That's crazy. The other one, though, this wasn't the one I was thinking of. The other one is a hard question on LeetCode. And it has to do with, like, it's not just an index. It's not just, like, it includes these vertical lines, like, as, like, blockers. As in, you have to find the total area based on the displacement of these. That one is disgusting. I mean, it's better because it's like, it doesn't look like this. It looks like it looks like this, where they're all next to each other, and then it's like, so like if this is a block and this is a block and this is 3 blocks, right? Between this and this, the max it can hold is this, and if this is a wall here, this will just overflow, so this will never hold anything. So if you did like this and then like this, right? This can only hold 2. So it's like this would technically be the max amount you could hold is 3. I hated that one. But yeah. Good solution. Oh wait, no, reopen. I need to submit this in Classic. Beautiful. Max number of k sum pairs. You're given an integer array nums and an integer k. In one operation, you can pick 2 numbers from the array whose sum equals k and remove them from the array. Return the maximum number of operations you can perform on the array. Oh. Well, that seems brute force very easy. Right? So, like, target is just going to be, if I'm going off the head just right now, for each in nums, target is equal to k minus each, right? And I just want to say if target in nums yeah, if there's duplicates, this doesn't work. So I do want to keep track of the index. So we are going to have I don't get how this is a 2-pointer problem, to be honest. It does feel like this would be just like a double for loop problem. I mean, I could do a left and right. Right. But this, And I could say while right is less than. It's so inefficient. If I say while right is less than the length of nums per se, right? And I say this would be left plus 1. I just put this at 1 for now. And I say okay. If nums at left plus nums at right is equal to k, delete nums at left, and delete nums at right minus 1 to account for that deletion. Unless it was before. Wait, no. Yeah. Right. Delete this and this. And then reset this. Or do a conditional. This is so messy. Right? Otherwise, reset these and just go back through. This is a recursive thing that I'm thinking of, though. Okay, fuck all of this. Let's restart here. This is too messy. I don't get how this can be a 2-pointer. What if I went back to my whole... Let's just see. This is a ChatGPT question. Right. Okay, this is what I was thinking, was doing this and then while left is less than right. If nums at left plus this equals k, do this, delete this and this. I think this is also not. Oh, if I delete right first, I don't have to de-increment left, yeah. And then move right down 2. Else if if this plus this, if left plus right is less than this, then we need to move this, otherwise. Oh, okay, that's smart. That's really smart. I think we still have max operations. And then we have our left and our right pointers, which is 0 and length of nums -1. This is what I was doing earlier, actually. Actually, if we just go all the way back to this disgusting thing, right? I had, well, right is less than left. I can say, and left is, left is 0, right is the length of nums -1. This is actually really smart of doing a sort, right? So if I do a nums.sort, then what I can say is, as long as right is less than the left pointer, if nums at left plus right equals k, we can increment this, and then we can delete the right value first, and then this. And then we can say, okay, the right value is going to be de-incremented by 2. We're going to de-increment it by 2 because we removed 2 elements. And then we're going to say, do we do anything else here? I know what I have the else, or elif, if nums at left plus nums at right is less than k, this else. Is this correct? No. 0. If left, what could ever be wrong here? This is the same exact thing. In what world would this, It never reaches that. Oh, while left is less than the right. My bad. I'm submitting this. I think it's just correct. Yeah, this is a nice little solution. What were other people doing for a 2-pointer here? Python 2, left, right, operation, y left is if this equals k, operation left plus equals 1, right. Oh, you just ignore them. That does make sense. You just straight up ignore it. And that way you also don't have to change. It still takes quite a while to run this. But, yeah. I mean, I'm assuming it's like the sorting. What beats? It's still a 2-pointer. I mean, this is all he has. As well nubs at right is greater than or equal to. While this value itself is greater than or equal to k. It's just like a preliminary thing. And then just calculating this. Okay, so he does this check of here, of just keep moving right if the right value is ever bigger than k, and then take this value. Oh. And this way I can just say if val, I like that. I like this whole thing of like, if I could see test cases, it just makes sense. Like if we have a huge array and the last number is 1,000, but k's like 8, why would we ever test all of this if we can just throw that pointer all the way down? Cool. Look at us go. Cool. Okay. Well, even though starting late, this is easily the longest we've done in a while, so very good. Give me some intriguing possibility. Okay. Good video. Did some linear algebra. Definitely need to refresh on that. Need to start going hard in the paint on computer architecture. I feel like a fraud in that. So we're gonna do a lot of work in that. LeetCode is feeling nice. Like you throw me in a technical interview right now, I am destroying that. I am going through these problems recently with quite a bit of ease. I mean, okay, I say that even though the last one we just did, I was kind of tripping up a little bit on it, but I don't know. I still feel like you put me in an interview right now, and I do very good at least, which is a great feeling. Um, which would be great if I actually got an interview, a single, just one. Anyways, yeah, good video. Like I said, I want to work on that task management application um, at some point this week. Tomorrow, actually, I have a lot of time. Hopefully, I can actually get a really nice video tomorrow. Working on computer architecture stuff. Looking at my, I think I'm going to be going home this weekend, so looking at that Apple II monitor setup thing, making my own operating system, you know, working intertwined with computer architecture, will be really fun. So yeah. Anyways, I have nothing more to say. I'm gonna enjoy the rest of my night. Probably play some games, and then go to bed. I only have one class tomorrow, which is linear algebra. So, like I said, a lot of time. I may even record in the morning and then pause it, go to class, come back, and then resume. Or not, or I'll have a not good day of recording tomorrow, but we'll see. So, enjoy the rest of your day, if it's not already over, and I'll see you tomorrow. Bye!